Here we go, a help video over problem number 5. This one is a challenging problem. Taking a look at this, we have to do the electron configuration for beryllium. On this one, apparently they didn't give us the atomic number, but we can find beryllium on the periodic table. We look right over here. There's beryllium, atomic number 4. It is in the 2s, and it is the second column in the 2s, so it should end in 2s2. So right away, we know it should be 2s2. We can go ahead and put in 2s2. That's where it should end. Now we jump up to square one and we fill in all the sublevels that take us to 2s2. That's only one. So we go back here. To get to beryllium, we start at square one. Hydrogen and helium are in the 1s. There's two elements, so it would be 1s2, 1s2, and now we're at beryllium. 1s2 is closed. Now we're at beryllium. It's the second one over, 2s2. And we should have it. How many total electrons is that? 2 and 2 is 4. We see up here in the little square, it's 4. So we know we have this correct. How many valence electrons does beryllium have? Valence electrons are electrons in the outermost level. The level number, the energy level number, is the big number in front of the sublevels. That's our first quantum number. It's the principal quantum number. My biggest number here is a 2, and there's 2 electrons in there. So it's a valence number of 2. What's beryllium's group number? We go back to here, we find beryllium, we go up, it's a Roman 2. Remember, for the main block families only, the S and the P's, these numbers on this top row will tell you how many valence electrons they should have. That doesn't apply to helium over here. It is its own case, it's an S2, which is why helium is sometimes put over here underneath the Roman 2. Because helium has 2, but they put it over there because the first level only holds 2. It has an s sublevel, which is made up of one orbital. Each orbital holds 2 electrons. That's why the first row of the periodic table of elements only has 2 elements present. All right, that'll take us to our next question. Number 6. And now we're doing ions. We've got several ions to take a look at. Our first one is indium 3+. Indium 3+. We've got to go to the periodic table of elements to find indium. There's indium right there, number 49, and it is in the 5p. It's the first element in the 5p. So before we do indium, we know it should end in 5p1. Before we even try to make it an ion, we know it should end in 5p1. So what I usually like to do is do indium, atomic number 49 by itself. It should end in a 5p1. We look above indium. We see that it's S2D10p1. So what's the D before indium? It's the 4D, so it should end in 4D10. So I can go ahead and put that right on my configuration, 4D10. I look above indium again, it's an S2. What's the S in front of indium? It's 5, so it should be 5s2, 4d10, 5p1, if I do this all correctly. 5s2, 5s2, 4d10, 5p1. I can put that down there. That's where it should supposed to end if I do it correctly. And then all I'm going to do is backfill the inner kernel. All the stuff on the inside is called the kernel. All right, how do I do that? I go up to square one. I start at square one. Hydrogen and helium, and we've done this a few times. Hydrogen and helium are in the 1s. There's 2 elements, so I would write 1s2. I now bounce down to the second row. On the second row, there's the 2s, lithium and beryllium, 2 elements, so I would have 2s2. I just continue to follow the numbers. Over to here, this is the 2p. See the 2p written right in there? 6 elements, 2p6. I put it right there. That takes care of the second row. Now I move down to the third row. 3s. The 3s has 2 elements in it. I write a 3s2. I then move on over to the 3p. The 3, there it is, 3p, 6 elements, 3p6. Now I move down to the next row. That's the 4s, 2 elements, 4s2. What comes after the 4s? The 3d. Why? Because it has an energy of 5, The 4s only has an energy of 4. That's greater energy. So that's what we have to fill next. How many are in that row? There are 10 elements there. 3d10. After that, I move to the 5p. After that, I move to the 4p. 4p, 1, 2, 3, 4, 5, 6. 4p, 6. Now I'm on the 5th row. I've just closed off that row. Now I'm on the 5th row. 5s2. There's the 2 elements in the 5s. 5s2. What's after that? The 4d. Why is the 4d after the 5s? The information up here will enable you to calculate that. Energy is the N plus the L. What's the N? The first number we see, 5, and the 4d, the N's are 4. Then they have a sublevel letter, but you have to convert the sublevel letter back to its quantum number. When you're in the D, the second number is a 2. So 4 plus 2 is 6. When you're in the S, your second number is a 0. 5 plus 0, because there's the 5 in front of the S. Replace the S with the 0. 5 plus S is 5. 4D is lower. It gets filled after. 4D10. 4D10. And now we are in the 5P. And it's the first one on the 5P. Why does the 5P get filled after the 4D? 4D, we already said the energy is 6. What's the energy of the 5P? Well, my first number is the 5, so that's my N. It's N plus L. But P is a letter. I've got to convert it back to its quantum number. P is 1. 5 plus 1 is 6. 5P has an energy of 6. The 4D also has an energy of 6. Ties go to the lower energy. 4 goes before 5. That's off by ordering. So we've got indium all finished. That's indium, not indium ion. So we've got to go back here. This is indium right up here. Now, how do I know it's indium? I already double checked it. It ended like we thought it should. But a last check is to add up the number of electrons to see if it equals the atomic number, because this is indium. 2 and 2 is 6 is 10, and 2 is 12, and 6 is 18, and 2 is 20, and 10 is 30, and 6 is 36, and 2 is 38, and 10 is 48, and 1 is 49. So all my electrons are accounted for. It equals the number of protons because it is neutral. But now they want us to do indium 3+. So where do we pull the valence electrons out of? You pull them out of the outermost level. So there's a 5, there's a 5. The 5p got filled after the 5s, so that one goes first. 0. Now a lot of students will want to go and pull them out of the 4d. Remember, the 4d does have more energy than the 5s, but it's actually inside the 5s. So the valence electrons get ripped off first. So 1 came out of the p, and 2 have to come out of the s, for a total of 3 electrons lost. Now we need to show, did that help indium by becoming a cation, by becoming 3+, does that help indium satisfy the octet rule? Well, these are gone and these are gone. The octet rule comes from the fact that elements become chemically stable. Atoms become chemically stable when they are left with a filled S and P, either by losing electrons or gaining electrons. So my S and P are now left full. The 4S has 2, the 4P has 6, 2 and 6 is 8. We are filled, and that is a wonderful thing. The next one is iodine 53. We're supposed to do the iodide ion 1-. In order to do that, it might be smart to do iodine first, and then it's 1-. We have to add an electron because there would be one more minus than positive. So I've got to find iodine on the periodic table. There's iodine right there. It's an S2D10P5. So I can go ahead and write down that is an S2D10P5. And I just wrote that over here so we don't have to really go back and forth too much. Now, what S2D10P5 is it? Well, we just come right back here. Iodine is a 5P, so it's a 5P5. So right here, even before I start, I can write 5P5. Which D is iodine in? I come right over here. The iodine just got filled after the 4D. So this is like the level here that I'm looking at. It should have 10 in the 4D. So I come right over here and write 4D10. Then previous to that, I'm just looking at this row right here. Previous to that, the 5S. How many were in the 5S? There should be 2 in the 5S. It says it here, and there's 2 elements there. So this is what it should end in if I do it all correctly. 5S2, 4D10, 5P5. So now I go to square 1. Square 1 has hydrogen and helium. That's the 1S. 1S2. I'm up here, 1S2. Now I go down to the 2P. There's 2 elements there, or 2S. There's 2 elements there. 2S2. Now I come over here to the 2P. There's 6 elements there in the 2P. Boron through neon is 6 elements. So I write 2P6. Now I'm at the 3S. There we go. I would write 3S2. Now I go over to here. 3P6. 3P6. I follow my numbers down. I'm just working from square 1 to iodine. And I'm just going left to right. Boom. Now I'm at the 3P6, 4S2. There's the 4S. There's 2 elements there. 4S2. Back to the 3D. 3D. How many elements are there? 10. So I write 3D10. Now I'm right here. 4P6. There's the 4P. There's 6 elements there. 4P6. Now I'm on the row with iodine on it. That's the level with iodine. 5S. There's 2 elements there, as we predicted. 4D10. 10 elements there, as we predicted. And iodine should be the 5th one over in the 5P. Iodine should be the 5th one over. Iodine should be the 5th one over in the 5P. There's iodine. 1, 2, 3, 4, 5th one over. All right. I think I've got it right. I can only know for sure by double checking my total electrons. 2 and 2 is 4, and 6 is 10, and 2 is 12, and 6 is 18, and 2 is 20, and 10 is 30, and 6 is 36, and 2 is 38, and 10 is 48, and 5 is 53. We've got it right. Now we want the iodide ion. That means there needs to be one more minus than there are pluses. There's 53 pluses, so there must be 54 minuses. I have to add one in. I have to add it in the level that was just being filled. I was in the process of filling the 5P. I add one to it. I have 6 in the 5P. And does that satisfy the octet rule? My octet rule says my outermost S and P or my S and P have to be left full. In this case, they lost them out of the S and P and it was left full on the inside. Here they added one to my outermost level, so now I check that. The 5S has 2 in it. The 5P6 has 6 in it. 6 and 2 is 8. It has satisfied the octet rule. In fact, by adding that one electron, it ends up with 54 electrons, just like xenon. It has the same electron configuration. We could call it like an isoelectric configuration. Iso means same configuration as xenon. That'll take care of our question on iodine. Our next video we'll pick up with on cobalt. If you have any questions on any of this, please do not hesitate to contact me to get additional help.